Hey guys, it's Mrs. Cameron here, and we are taking a look at CLT practice test number 3. And we left off on question number 117, which says, how many integers between 100 and 999 inclusive meet both of the following conditions? 1. The sum of the integer's digits is evenly divisible by 3. And 2, the integer is not divisible by 9. So when we look here, I know that up to 999, right? If a number is divisible by 3 and its digits are also evenly divisible by 3. That's from our divisibility rules. So your divisibility rules for your 3s and your 9s are what's going to help you get through this question fast. Divisibility rules. Okay, so if we take 999 and divide it by 3, we'll know how many numbers are divisible by 3. And then we have to subtract out the numbers 1 to 99 that are divisible by 3. And this will tell us how many numbers meet condition 1. So 999 divided by 3 would be 333, minus 99 divided by 3 would be 33. So that's 300 numbers meet condition number 1. But then we need to take out our numbers that are not divisible by 9. So we're going to say 999 divided by 9, and then take away the numbers that are number 1 through 99 and are divisible by 9. So that'd be 111 minus 11 would be 100. So that leaves us with 200 numbers that meet the conditions together. So we had to take our 300, which are the amount of numbers that meet condition number 1, and then we had to subtract out the numbers that overlap that also meet condition number 2. And then moving forward to question number 118, line P is horizontal and is tangent to the circle x plus 3 squared plus y minus 1 squared equals 9. Line Q is vertical and is tangent to the circle x minus 6 squared plus y plus 2 squared equals 25. Which of the following could be a point of intersection of lines P and Q? So I want to look at this on a graph. So I'm going to draw out my coordinate plane here. And this is going to go to the side. And then to graph a circle from the equation, this is not something that I do real often in class, but looking at the equation like this, I can see that for this first circle, these values here, it should be x minus our x coordinate for our center and y minus our y coordinate for our center. So the center of this circle would be at x is negative 3 and y is positive 1. So 1, 2, 3, up 1 is the center of this circle. Actually, I'm going to make this another color. Sorry. The center of this circle here. And my radius is going to be the square root of 9, which is 3. So from there, it goes up 3. 1, 2, 3, and down 1, 2, 3, and over 3, and out 1, 2, 3. So our circle looks something like up 1, 2, 3, down 3. Excuse me. And okay, and then it's a circle. So something like this. Okay, and with this circle, it's P. Line P is horizontal. Horizontal means it's like the horizon, it goes side to side, and is tangent to this circle. So that means that line P either goes like, we'll make it gray. Line P, it could be a horizontal line here at y equals -2, or up here where y equals 1, 2, 3, 4. Either y equals 4 or y equals -2. Okay, and now my next circle. I'm going to make it purple. Purple circle. Over here, our coordinates for our center is +6 and -2. 1, 2, 3, 4, 5, 6, down 2. There's the center of our circle, so I'm going to guess this is not what we want because that's cutting through our other circle. And the radius of this is going to be 5. So it's going to come out another 5 and down 5. 1, 2, 3, 4, 5. Okay. And then back to my purple circle. So here was the center, and it goes up 5 from there. 1, 2, 3, 4, 5-ish. And down 5. Out 5. And back 1, 2, 3, 4, 5. And my purple circle. There we go. Okay. And okay, so this says that line Q is vertical. So verticals, like vertical blinds, go up and down, and is tangent to this circle here. So it's vertical straight up and down, and it goes through this x equals +1, or it goes through this x equals wherever we're out here. So these two lines intersect here, 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 and here, where P is my y value, Q is my x value. Okay. Which of the following points could be a point of intersection of lines P and Q? So it could be any of these. I don't have any where x is 1. Out here, x is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. X is 11, and y is up 1, 2, 3. Y is 4. Right here, we have 11, 4. So those lines P and Q are intersecting here. It could have also been 11, -2. It could have been over here at x's 1, y is -2, or up here at x is 1, 4. But these three options were not here, so it had to be this one. And then question number 119 says, it's a long long word problem. The potential energy designated by U that is associated with the position of an object on a given planet is given by the following equation. U equals mgy, where m is the object's mass, g is the acceleration due to gravity on that planet, and y is the height above some reference point. A physicist calculates the potential energy of an object with mass m on Earth. He then calculates the potential energy of that same object with identical mass on planet Z when the height of the object over a reference point is doubled, and the acceleration due to gravity is 1/6 that of Earth's. Based on these calculations, what is the ratio of the potential energy of the object on Earth to the potential energy of the object on planet Z? So on Earth, oops, bring my writing pad over here. Okay. On Earth, we have U equals mgy, where we have planet C is 1/6 that of Earth. So planet Z U equals mgy. The potential energy designated by U. Equations where m is the object's mass. So, what is the ratio of the potential energy of the object on Earth to the potential energy? So, I think I can just put in, like, it just says the same object. So, I'm just going to make up a mass because they're not telling me, like, the mass is this for this. So, I'm just going to say whatever the object is, it has a mass of 5. So, on both of these, U equals 5. Same object, right? And g is the acceleration due to gravity. And it says the acceleration due to gravity is 1/6 that of Earth. So Earth has acceleration due to gravity 6 times more than this. So I'm going to make this one be 1. And y is the height above some reference point. A physicist calculates the potential energy of an object with mass m on Earth. He then calculates the potential energy of that same object with identical mass m on planet Z when the height, okay, here we go. Here's the height stuff. When the height of the object over a reference point is doubled. Okay, so on Earth, if we say it's at 2, double it. 2 times 2 is 4 on planet Z. Now, what's the ratio? So, of potential energy on Earth to Z. So, E to Z. So, let's solve this out. 5 times 6 is 30, times 2 is 60. And 5 times 1 is 5, times 4 is 20. 60 to 20, both are divisible by 20. 60 over 20. 60 divided by 20 is just 3. So our answer is D. And I made up some numbers to plug in there because they didn't tell us exactly. And if you had made up different numbers, as long as everything was in the correct ratio, you would have gotten the same answer as me. And now we're on the last question for practice test number 3, question number 120. And I'm out of time. I'll catch you on the last video.